Have you ever looked up at the night sky and felt a sense of wonder? The stars, the planets, the vastness of it all, it's humbling, isn't it? Now imagine that everything we see, everything we know about the universe is just a tiny piece of something much, much bigger. It's a mind-boggling thought, the idea that our universe, as vast as it is, might not be the only one. What if there are other universes out there, hidden from our view? Universes with different laws of physics, different realities, maybe even different versions of ourselves. This isn't just science fiction, though it certainly sounds like it. Some of the most brilliant minds in science are exploring the possibility that we live in a multiverse, an endless expanse of universes, each with its own unique story to tell. It all starts with a theory about the very beginning of our own universe, a theory that suggests the existence of something beyond. We call it the Big Bang, that moment of creation when our universe burst into existence. But what happened right after the Big Bang? Picture this. The universe, still in its infancy, expanding incredibly fast, much faster than anything we can imagine. This rapid expansion, known as inflationary cosmology, is a key piece of the puzzle. It helps explain why our universe looks the way it does today, the even distribution of galaxies, the faint afterglow of the Big Bang. But it also hints at something more. Some physicists believe that while our universe eventually slowed down, other regions of space kept inflating, creating separate bubble universes. Imagine blowing soap bubbles into the air. Each bubble is its own little world, separate from the others. In the same way, these bubble universes would be separate from ours, each with its own set of physical laws, its own unique properties. Our universe, then, would be just one bubble in a vast cosmic foam surrounded by countless others. Think about that for a moment. If this is true, our cosmic address becomes a bit more complicated. We're not just in a certain galaxy in a certain part of the universe, we're in a specific bubble universe, one of perhaps an infinite number. It's a dizzying concept and it raises more questions than it answers. How did these bubble universes form? What are they like? Could we ever contact them or even visit them? These are questions that scientists are still grappling with, but the very idea of a multiverse challenges our understanding of reality itself. It tells us that our universe, with its familiar stars and galaxies, might be just one of many possibilities, a single page in a cosmic storybook of unimaginable size and scope. To understand how we arrived at the mind-blowing idea of a multiverse, we need to take a trip back in time, to the very beginning of everything, the Big Bang. Now, the Big Bang wasn't just an explosion in space, it was the beginning of space and time itself. In the first fraction of a second after the Big Bang, something incredible happened. The universe, still a tiny speck of unimaginable heat and energy, began to expand. And we're not talking about your average, everyday expansion. This was an expansion on a scale that's almost impossible to grasp. Imagine a tiny dot, smaller than an atom, suddenly swelling to become billions of light years across in less than a blink of an eye. That's the kind of rapid expansion we're talking about. It's called inflationary cosmology, and it's one of the most important ideas in modern physics. This period of rapid inflation helps explain some of the most fundamental properties of our universe, like why it looks so smooth and uniform on the largest scales. You see, if the universe had just expanded at a normal rate, there wouldn't have been enough time for different regions of space to even out and reach the same temperature. Think of it like baking a cake. If you don't mix the batter thoroughly, you'll end up with pockets of flour and sugar scattered throughout. But if you mix it really well, the ingredients will be evenly distributed, and the cake will have a consistent texture. In a similar way, the rapid expansion during inflation acted like a cosmic mixer, smoothing out any initial irregularities, and creating a universe that's remarkably uniform on the largest scales. And we can actually see evidence of this early period of inflation in the faint afterglow of the Big Bang, the cosmic microwave background radiation. This faint glow, which permeates all of space, is like a baby picture of the universe, showing us what it looked like just 380,000 years after the Big Bang. And when we study this cosmic baby picture, we find that it's incredibly smooth, with only tiny temperature variations from one point to another. These tiny temperature fluctuations are like the seeds from which galaxies and clusters of galaxies eventually grew. But the fact that they're so small tells us that the universe must have been incredibly smooth and uniform in its earliest moments, just as inflationary cosmology predicts. Now here's where things get really interesting. While our region of space eventually stopped inflating so rapidly, some physicists believe that inflation never completely stopped in other parts of the universe. Instead, it continued on, creating vast regions of space that expanded at an exponential rate. Imagine a pot of boiling water. As the water heats up, bubbles form at the bottom of the pot and rise to the surface. In a similar way, these regions of continuing inflation would have created bubble universes within a larger, expanding multiverse. Each bubble universe would have been like a seed, inflating rapidly and eventually cooling down to form its own unique universe, complete with its own set of physical laws and constants. Some of these bubble universes might be similar to ours, with stars, galaxies, and maybe even life. But others could be radically different, with completely different types of particles, forces, and even dimensions. It's like imagining a vast cosmic ocean filled with countless bubbles, each one a unique and separate universe with its own story to tell. And our universe, the one we know and love, would be just one bubble in this vast cosmic sea. It's a mind-blowing concept, and it raises all sorts of questions about the nature of reality itself. Are these other bubble universes really out there? And if so, could we ever hope to contact them or even visit them? These are questions that scientists are still grappling with, but the very idea of a multiverse challenges everything we thought we knew about the universe and our place within it. Imagine the universe as a vast and intricate tapestry woven with threads of space and time. Now picture our universe, the one we call home, as just one small patch of fabric within this grand cosmic design. The idea of bubble universes takes this metaphor a step further, suggesting that our universe is just one bubble among countless others, each a separate and unique entity floating within a larger multiverse. It's a mind-boggling concept, the notion that our reality, as vast as it seems, is just a tiny pocket within an even grander and more complex reality. These bubble universes wouldn't be mere copies of our own, with slight variations here and there. Instead, they could be radically different, governed by entirely different laws of physics. Imagine a universe where gravity is weaker, causing stars and planets to drift apart like cosmic dust motes. Or perhaps a universe where the speed of light is slower, affecting how stars shine and how energy travels through space. In these alternate realities, the very fabric of existence could be different, leading to outcomes we can barely begin to fathom. The idea of bubble universes emerging from inflationary cosmology might seem like pure speculation, but it's rooted in some of the most fundamental principles of physics. The same forces that shaped our universe, the same laws of nature that govern the behavior of matter and energy, could have played out differently in other regions of the multiverse. Think of it like baking a batch of cookies. Even though you use the same dough and the same oven, each cookie will come out slightly different with its own unique shape and texture. In a similar way, the conditions within each bubble universe could have led to vastly different outcomes, even if they all started from the same initial state. But here's the catch. These bubble universes, if they exist, would be forever beyond our reach. The rapid expansion of the multiverse would have pushed them far beyond our cosmic horizon, the limit of what we can observe from Earth. It's like trying to sail to the edge of the world. No matter how far you travel, you'll never reach the end, because the Earth is a sphere. Similarly, no matter how powerful our telescopes become, we'll never be able to see beyond our cosmic horizon. But even though we may never be able to directly observe these other bubble universes, the very idea of their existence has profound implications for our understanding of reality. It suggests that our universe, with its particular set of physical laws and constants, might not be so special after all. Perhaps there are countless other universes out there, each with its own unique set of conditions, its own story of cosmic evolution. Some of these universes might be hospitable to life, while others might be barren and lifeless. The possibilities are truly endless, limited only by our imagination. And who knows? Maybe in some distant corner of the multiverse, there exists a universe where the laws of physics are so bizarre, so utterly alien to our own that we can't even begin to comprehend them. The concept of bubble universes challenges us to expand our view of reality, to embrace the possibility that our universe is just one small part of a much grander and more mysterious cosmos. It's a humbling thought, but also an exhilarating one, reminding us that there's still so much out there to explore and discover. So far, we've journeyed through the cosmos on the wings of inflationary cosmology, contemplating the mind-boggling possibility of bubble universes scattered throughout a vast multiverse. But the story doesn't end there. Another path leads us deeper into the fabric of reality, a path paved with the elegant mathematics of string theory. Imagine for a moment the smallest particles that make up everything we see and touch, the atoms, the protons, the neutrons, even the tiny electrons whizzing around them. Now imagine those particles not as tiny points but as minuscule vibrating strings, like the strings of a cosmic violin. That's the essence of string theory. The idea that the fundamental building blocks of the universe aren't particles at all but tiny one-dimensional strings, and just like the strings on a violin can vibrate at different frequencies to create different musical notes, these cosmic strings vibrate in different ways to create the particles and forces we observe in nature. It's a beautiful and elegant theory, one that has the potential to unify all the forces of nature into a single, coherent framework. But here's the catch: for string theory to work mathematically, our universe can't have just the three dimensions we're familiar with, length, width, and height. It needs extra dimensions, curled up and hidden from our view, like tiny, intricate folds in the fabric of space-time. Now you might be thinking, extra dimensions? That sounds like something out of a science fiction novel. And you wouldn't be entirely wrong. The idea of hidden dimensions is certainly mind-bending, but it's a natural consequence of string theory's elegant mathematics. Think of it like a garden hose. From a distance it looks like a one-dimensional line, but if you were an ant crawling along its surface, you would experience it as a two-dimensional world. You could move forward and backward along its length, but also around its circumference. Similarly, string theory suggests that our universe might have extra dimensions curled up at every point in space, too small for us to perceive directly. And just like there are countless ways to coil up a garden hose, there could be a vast number of ways to arrange these extra dimensions. And here's where the connection to the multiverse comes in. Each different arrangement of these extra dimensions would lead to a universe with its own unique set of physical laws and constants, just like each different tuning of a guitar produces a different melody. Imagine a vast and sprawling landscape, with every point on that landscape representing a different universe, each with its own unique set of physical properties determined by the way its extra dimensions are curled up. This is what physicists call the string landscape, a mind-boggling expanse of possibilities, a cosmic menu of universes. Some of these universes might be similar to ours, with stars, galaxies, and maybe even life, but others could be radically different, governed by forces we can barely imagine. Universes with more than 3 spatial dimensions. Universes where gravity is as weak as a gentle breeze. Universes where time itself flows differently. The string landscape paints a picture of a multiverse far grander and more diverse than anything we could have imagined. It suggests that our universe, with its particular set of physical laws and constants, might be just one random point on this vast landscape, one particular melody played on the cosmic strings. It's a humbling and awe-inspiring thought, one that challenges us to expand our understanding of reality itself, but it also raises more questions than it answers. How did this string landscape come to be? And if there are countless other universes out there, could we ever hope to learn anything about them, to catch a glimpse of these other realities hidden within the fabric of space-time? These are questions that physicists are still grappling with, questions that lie at the very forefront of our quest to understand the universe and our place within it. Up until now, our journey through the multiverse has taken us to the grandest scales imaginable. Expanding bubble universes, hidden dimensions curled up within the fabric of space-time. But what if the key to understanding the multiverse lies not in the vastness of the cosmos, but in the tiniest realms of existence, the strange and counterintuitive world of quantum mechanics? Quantum mechanics is the branch of physics that governs the behavior of matter and energy at the atomic and subatomic levels. It's a world where particles can exist in multiple states at once, where the act of observation can influence the outcome of an experiment, where the very notion of a definite reality seems to break down. One of the most mind-boggling aspects of quantum mechanics is the idea that at the subatomic level, events are governed by probability rather than certainty. It's like rolling a dice. You know the possible outcomes, but you can't predict with absolute certainty which number will come up. This inherent randomness in quantum mechanics has puzzled physicists for decades. How can the universe, at its most fundamental level, be governed by chance? It's like the universe is constantly flipping a coin, deciding which outcome will become reality. This is where the many worlds interpretation of quantum mechanics comes into play. Proposed by physicist Hugh Everett III in the 1950s, this mind-bending interpretation suggests that every time a quantum measurement is made, every time a dice is rolled in the quantum realm, the universe splits into multiple copies of itself, one for each possible outcome. Imagine you're conducting an experiment where an electron can either spin up or spin down. According to the many worlds interpretation, when you measure the electron's spin, the universe splits in two. In one universe, the electron spins up. In the other, it spins down. But it's not just electrons and their spins. Every quantum event, every interaction between particles, every random fluctuation in the quantum foam would create a new branch in the multiverse, a new timeline, a new reality. It's like imagining a tree growing at an unimaginable rate, with each branch representing a different possible outcome of every quantum event that has ever occurred, is occurring now, and ever will occur. This means that somewhere out there in the multiverse, there's a universe where you made a different choice this morning, a universe where you took a different path in life, a universe where history unfolded in a completely different way. In fact, there's a universe for every possible outcome of every decision you've ever made, every action you've ever taken, every thought you've ever had. It's a dizzying and almost overwhelming concept, the idea that there are countless versions of ourselves out there, living out every possible permutation of our lives. It's like the universe is a vast and intricate tapestry, woven with threads of every possible choice, every possible outcome. But here's the catch. Just as we can't see beyond our cosmic horizon to observe other bubble universes, we can't interact with these other quantum realities. They exist alongside our own, but forever separated, like parallel lines that never intersect. The many worlds interpretation is a radical and controversial idea, one that challenges our fundamental understanding of reality itself. It tells us that the universe is far stranger, far more complex, and far richer in possibilities than we could have ever imagined. It's a universe where every quantum dice roll, every random fluctuation, every fleeting possibility has a reality of its own. It's a universe where the tapestry of existence is woven with an infinite number of threads, each representing a different path, a different story, a different outcome. And while we may never be able to directly observe these other quantum realities, the very idea of their existence expands our view of the cosmos, reminding us that the universe is a place of infinite wonder, infinite mystery, and infinite possibility. Our journey through the multiverse has taken us from the grandest scales of bubble universes to the tiniest realms of quantum mechanics. We've glimpsed the possibility of countless other realities, each with its own unique set of physical laws, its own story of cosmic evolution. But this journey inevitably leads us to a profound question. Why is our universe the way it is? Why does it seem so perfectly suited for life, for stars, for galaxies, for us? Think about it. The fundamental forces of nature, the constants that govern the behavior of matter and energy, are balanced on a razor's edge. If gravity were just a tiny bit stronger, stars would burn out too quickly for life to evolve. If the electromagnetic force were slightly weaker, atoms wouldn't hold together. It's as if the universe, in its vastness and complexity, was fine-tuned for our existence. This apparent coincidence, this cosmic balancing act, has led some scientists to propose a fascinating idea: the anthropic principle. The anthropic principle, in its simplest form, states that the universe must be compatible with the existence of observers. That's us, because we're here to observe it. It's a bit of a circular argument, but it does raise some intriguing questions. Imagine a vast cosmic lottery where every ticket represents a different universe, each with its own unique set of physical laws and constants. Most of these universes, perhaps an overwhelming majority, would be completely inhospitable to life. Stars might not form, galaxies might not coalesce, or the fundamental forces might be so out of whack that matter itself couldn't exist in a stable form. But in a tiny fraction of these universes, the conditions would be just right for life to emerge, for stars to shine, for planets to form. And it's in these rare life-permitting universes that observers, conscious beings capable of pondering their own existence, would eventually arise. Now, you might be thinking, wait a minute, isn't that a bit self-centered? Are we really saying that the universe revolves around us? The anthropic principle isn't suggesting that we're the center of the universe or that the universe was somehow designed with us in mind. Instead, it's a matter of perspective. If we accept the possibility of a multiverse, a vast ensemble of universes with different properties, then it's not surprising that we find ourselves in a universe that can support life. It's like winning the lottery. The odds of winning are incredibly small, but someone has to win eventually. And in the cosmic lottery of the multiverse, we're the lucky winners who get to experience this particular reality, this particular set of physical laws that allow for our existence. The anthropic principle doesn't provide any direct evidence for the multiverse, but it does offer a thought-provoking framework for understanding our place within it. It suggests that our existence, rather than being a cosmic accident, might be a natural consequence of the vastness and diversity of reality itself. It tells us that our universe, with its seemingly fine-tuned properties, might not be so special after all. It might be just one life-permitting oasis in a vast cosmic desert, one island of habitability in an ocean of possibilities. And somewhere out there, in another corner of the multiverse, other observers might be gazing up at their own night skies, pondering the same cosmic mysteries, wondering if they too are alone in the vastness of existence. We've traveled far on this journey, from the first moments after the Big Bang to the strange realm of quantum mechanics. We've imagined bubble universes, hidden dimensions, and endless quantum realities. It's a tapestry woven from the most cutting-edge science and the most imaginative speculation. But a question lingers, a question that whispers through the corridors of our minds. Can we prove any of this? Can we find concrete evidence that the multiverse is more than just a captivating idea? The answer, at least for now, is not quite. The very nature of the multiverse, with its separate, self-contained universes, makes direct observation incredibly difficult, perhaps even impossible. It's like trying to hear a whisper from a distant star, a whisper lost in the vastness of space. We can't simply point our telescopes at the sky and expect to see other universes waving back at us. The expansion of the multiverse, the very thing that might have created these separate realities, could have pushed them beyond our reach, forever hidden behind the cosmic horizon. This lack of direct evidence leads to another challenge. If we can't directly observe the multiverse, can we even call it a scientific theory? Some critics argue that if an idea is not testable, if it doesn't make predictions that we can confirm or refute through observation or experimentation, then it falls outside the realm of science. And yet, the allure of the multiverse persists. Scientists continue to explore its implications, to search for subtle hints of its existence hidden within the data we collect about our own universe. Perhaps we'll find those fingerprints of inflation, those subtle patterns in the cosmic microwave background radiation that point to a time when our universe was just one bubble in a much larger cosmic foam. Or maybe as we refine our understanding of string theory, we'll discover ways to test its predictions, to glimpse those hidden dimensions that could hold the key to the multiverse. The search for evidence is a journey in itself, a testament to the insatiable curiosity that drives us to explore the universe and our place within it. So, where does that leave us? The multiverse remains a tantalizing enigma, a realm of possibilities that stretches the limits of our imagination. We may never know for certain if other universes exist, if other versions of ourselves are out there living out different versions of our lives, but even if the multiverse remains forever beyond our grasp, the very act of contemplating its existence changes us. It reminds us that our universe, vast and ancient as it is, might be just one small part of a much grander and more mysterious reality. It humbles us, reminding us that we are still learning, still exploring, still piecing together the puzzle of existence. And it inspires us, urging us to push the boundaries of our knowledge, to seek answers to the biggest questions we can ask. Whether or not the multiverse is ever proven, it has already enriched our understanding of the cosmos and sparked our sense of wonder. It reminds us that the universe is a place of infinite possibilities, a place where even the most mind-boggling ideas might turn out to be true.